Welcome to part 2 of the Getting Started series for the Peel 3. In this tutorial, we're going to look at how to use peel.cad to extract information from a 3D scan from peel.os. So what we need to do is launch peel.os and we need to select Open File. You then need to find the peel.cad session file that you previously saved from part 1 of the video. If needed, however, and you can actually import a mesh from a peel.os session file into peel.cad. So we may look at that as well. So I'm just going to open up the peel.cad file first and foremost. And then I'm going to show you how you can import a mesh into peel.cad once you're in this environment. So you can go import mesh and you import the peel.os session file. And that will essentially just pull in only the mesh. So it's now brought in the mesh only, okay? But obviously it's not the aligned version like I already exported to peel.cad. So just wanted to show you that. Okay, so we're now going to look at how we can extract some information from this part and transfer it over to SolidWorks. So the first thing I want to do is a more precise alignment here in peel.cad. So I'm going to create a plane. Holding Control, I'm going to select this plane here and select OK. Next, I'm going to create a cylinder. And what I can do, which is quite nice, is I can ensure that when I create the cylinder, so I'm going to hold Control and click on it, I can determine the orientation. So I want that to be normal to plane 1. So I can make sure that it's perfectly 90 degrees to plane 1. And that's quite important, especially for reverse engineering, to make sure angles are correct. And then press OK. And then I want to do one more entity. So why don't we make a circle here that I can lock onto. So I need to go and create a plane. Select the plane, holding Control and click on the plane, accept, press OK. Then I'm going to select the circle tool and I want to then project that onto plane number 2. So create the circle, choose the plane to constrain to, and now we can select the circle. So what's nice with all of the tools is that it will put you into the correct selection tool for the job. So it's automatically found similar curvature, hold Control and click. If it hasn't selected enough of the data, I can then drag the selection tolerance higher for it to select more of the scan data. So you can see it's selecting more of that hole. And under the diameter, under constraints, diameter is saying that it's 6.897. So you might say that that's a 7mm hole or a 6.9mm hole. So you can overwrite the dimension if you wanted to. Press OK, and then we can hit cancel. So we now have enough entities or information that we can use to create our alignment. So first things first, I want to click on the manual alignment tool. I'm going to select plane 1 and I'm going to set that to X and Z. Next, I'm going to select cylinder 1 and I'm going to set that to Y. And last, I'm going to select circle 1 and that's going to be my X axis. So it's put the origin onto the actual main cylinder. And I'm just going to turn off the perspective view to look at the orthographic, and I can just check and see whether or not that's being properly aligned, which it has, and I can now accept that. But what's really quite cool about the peel.cad is that I can go over to meshes under alignment. I've got manual alignment 1, or I've got the older alignment, so I can actually activate that older alignment if I actually wanted that, or activate the main alignment that I've just completed. So now that I've got these entities and done my alignment, I can now start to extract any information that I may need. So I need to get some more holes. So I'm going to go get the plane tool, hole control, and just create another constraining plane. And I might be able to just extrude that a bit bigger. Okay, and accept. And I might just create another plane here. Okay, accept. You can also like click on a plane in the 3D view and it will find it over here. I can't do anything with that. I can right click and export it, but it will just find it over here on the left hand side, which is quite useful. Okay, so now that I've got those, I now need to extract the entities that I want. So this is actually a cylinder because it actually continues on past here. So I'm going to go and get the cylinder, and I'm going to make its orientation normal to the y-axis. So I'm going to hold control and then click on the cylinder there. Again, increase the selection tolerance. Just grab a little bit more data and then jump to the other side of the hole and get a little bit more. And then I can just make that cylinder go out past each end. Okay, and so it's saying that it's a 7mm hole essentially. So I could either make it 7mm or 6.9 like I had the other hole. It's really up to you what you decide what the hole is, or you just stick with the actual measurement. Okay, we can accept that, and then we'll create a couple of holes now on this particular plane. So we click on the circle tool, select the plane that we want to constrain to, plane number 2. I've got the right selection tool for the job. Now I can just go and hit control and grab that selection. Now it's not projecting properly up onto that plane, so I need to make sure I've got the right plane. Sorry, I had the wrong plane. It was projecting lower because I had the wrong plane. So I've now projected onto that, and we'll make that a 5mm hole. Okay, accept, and it keeps the parameters that I had set for circle number 2 for my next circle. So I can just hit control now and just automatically create a 5mm circle projected onto the correct plane. Okay, so I've got the main entities sorted now for my part. I can accept that. And then I can cancel creating any more additional holes. So next what I want to do is most likely a save. I need to save it. So I'm just going to go save as, because I might provide this file for people to play with. We'll call this one the result, so the finished file, because we'll eventually get there. So what I want to do next is I want to go and cut the mesh. And I want to select the plane I want to use to cut. So I'm going to select plane 4 to begin with. And just bring my cutting plane way smaller over to where I want to cut. I don't really want to keep both sides. I'm going to get rid of that. I'm going to flip the normal so that the arrow's pointing downwards, pointing to what I want to keep. So wherever the arrow's pointing is what you're going to keep. And I'm just going to pull this down approximately, let's just look at and see what 1mm does. I think that would be okay for what we want to do. Okay, and I can preview that, and you can see it's only cut what it was crossing. So I'm happy with that now, and we're going to hit OK, and it will just chop that off. And I haven't filled the boundary. I didn't want to do that. I'm going to do that later. So we just need to do a few more cuts. So I'm going to do another cut. I'm going to choose plane number 2. Just pull that down. Now this is the plane I want to cut. don't need to keep both parts. I want to flip the normal and just cut that down. And we'll do 1mm as well. So we'll just do 1mm all around. Again, I don't want to keep both parts. Preview it, accept it. Okay, cut plane again, or cut mesh, sorry. Select the right plane, adjust the planes that you're cutting, flip the normal and untick keep both parts. And again, preview. Okay, happy with that. So after doing all of that, we can just turn off the visibility of the entities just to show what's available. So that's looking pretty good. I could then go to a connect selection, hold control and click on what I want to keep. And then you can see there's some floating bits that are grayed out. I don't need them anymore. I've extracted my circles. So why don't we go ahead and just hit keep only, selected, and it will just delete anything that's not selected. Next, I want to get rid of this hole. So I could get my lasso tool. I could go to select through, and I just want to make sure I select right through that. Just make sure I get a nice big selection. And then I would then just hit defeature, and it just takes away that hole. For this hole over here, I'd probably be inclined to delete it and then just hole fill. So we'll come back to that one. But first what we want to do is we want to extrude these boundaries. So I want to click on the extrude boundary tool, click on this hole here. I want it to fit onto my plane number 3. So it's fitted onto that, but it's also added +1, as you can see here. So plane offset 1. If it had been 0, it would be perfectly on the plane. But I actually want to take it further because I'm going to cut it off in SolidWorks. And what's quite nice is that as you're doing this, extruding the boundary, you can also add a bit more tension, and it will just kind of like improve the boundary of the hole. So the greater the tension, the smoother your boundary. And then I can also fill the boundary, which is actually what I want to do. You may also select the more smoothing layers, so it just creates a kind of smoother finish, which it has. So that's exactly what I wanted to do. I just wanted to create a nice flat end, which we're going to cut off. Okay, let's repeat that. Click on that, plane number 3, +1mm, fill the boundary, apply. Repeat again, select that, but this time it will be plane number 2, +1mm, fill the boundary, apply. Give it a bit of time. That's good. And then the next one here, this is going to be plane number 4. And this time I don't want the tension to be so good because that was so high, because it's going to take away the shape of my actual part. So looking at it, it's still a bit high. We'll probably go like 25. That's looking a bit better, you know, it's still within the look of the shape. Okay, that's looking pretty good there. Then we can go OK. Then over here, I just actually want to take away completely this hole. So if I go to a top view, I'm going to go to hole filling. And you can still select and delete while you're in the hole filling menu. So I'm going to go and get the paintbrush, select through turned on, and just zoom out. Holding control, I can then roll my wheel forward on my mouse, which essentially just drags that slider for the brush size up, and just go and grab that. And so you want to make sure that you've got obviously enough selection there, but not too much to lose the details that maybe you wanted to keep. Okay, that's looking pretty good. We can hit delete. And then we're going to switch that to a flat fill. So again, whole fill, flat fill, and just click on the boundary and just remove that. So we're making it more of a shape that we're going to then turn into a solid. And just removing these entities and then putting them back in CAD will give us more clean holes or bosses to work with. So I want to do a bit of a smooth. So I'm going to click on under the improve section, the smooth tool. We've now got low, medium, high, smooth levels. So you can just hit apply and just see what it does. That looks pretty nice actually. Quite happy with that. We can press OK. If there's any areas in particular that you just, it's looking a bit rough, you can get the sandpaper tool, increase the brush size a little bit or decrease it in this case, and just drag over and just smooth those out. So you're completely in control of the kind of like mesh level of detail. And sometimes you might just actually delete it and just whole fill, Another quite cool tool is called spike removal. So if I click on that, it goes ahead and finds any spikes in your model. But be careful, it might take away some of these edges. Hit apply, and it will just take those away. And then finally, before doing any auto surfacing, I typically would do a clean mesh, and that will go through and just find any self intersection, spikes, creased edges, that sort of stuff. Hit apply, and then we're going to get the final mesh. And if we just check it, we're going to go right click properties. It's watertight, so it's technically, if you wanted it to be 3D printable, but it's definitely solid for surfacing. And at this point, I'd recommend having a save. So if we wanted to auto surface this, we could click on this button here, which is auto surface. And I would recommend for this one, maybe about 5,000 patches. I like to have a few more control points and just hit preview. And it will go ahead and just basically shrink wrap NURB CAD surfaces over top of the scan data. So while we're waiting, these are all the primitive entities you can add. We can copy meshes, we can duplicate them. Under improve, we can edit boundaries, reduce triangle count by decimating, whole fill. We can surface offset, we can offset boundaries, cut meshes with a curve, mirror meshes, flatten a 3D surface, sculpt, rewrap a mesh watertight, scale an object. So edit's quite powerful. Okay, so we have our mesh now, our NURB surface, and it looks like it's done a good job of surfacing over top of the scan data. So next what we're going to do is, while we're in this preview mode, we can then compare the auto surface back to the mesh surface, just to see how tight the fitting of the mesh was. How tight the fitting of the NURB surface was. And it can take a little bit of time to calculate. Okay, maybe I need to go OK first, and then go to compare. Sorry, so go to compare, then to compare to auto surface. Go back to the main navigation menu and just turn off the visibility of the auto surface, which will compare the mesh to the auto surface. And you can see it's within 27 micron, the results. So if I went back to compare, I could say maybe I want to visualize that at 10 micron, and it will start to show you where potentially you're losing a little bit of resolution. But on a whole, the tightness of the fit of the auto surface is very good. I'd be happy with anywhere from 25 microns upwards, which is mostly green. Okay, so we now have our auto surface. Let's turn off our mesh, and let's just turn on the entities that we want to send over to SolidWorks. So these are all the entities that we are going to transfer. So typically what I like to do is just do the main entities first, and then I do the auto surface later. So let's right click on those entities, and then you can choose transfer to SolidWorks, or you can go over to here and click transfer to SolidWorks on this button after selecting what you want to transfer. We can also transfer to SolidWorks, Inventor, Fusion 360, and now Solid Edge. Well, Solid Edge was actually always there. Fusion 360 wasn't. So Fusion 360 is the latest option we have. Okay, so we've got to click on transfer to SolidWorks, and it will go ahead and launch SolidWorks for you and create a part file and import those entities directly into the SolidWorks environment. Cool, so I've got those planes in there in a cylinder. It doesn't really give us much context, but the cylinders have come in as solids, and the planes and circles have come in as an actual SolidWorks plane and actual SolidWorks circles. So next we need to transfer the auto surface. So we go back to peel.cad, select the auto surface, and then just click transfer to SolidWorks. And it will go ahead and transfer that directly into the same part file. So as an example, what that means is that you can come back into peel.cad, extract some more information from the mesh, and then add it to your SolidWorks part file and just keep adding and adding as much as you like, essentially, which is really useful for just working between scan data and CAD data. One thing I didn't mention as well is that under entities, we can create cross sections in the entity section and create like a polyline outline of a cut through the mesh, which you could then use in SolidWorks to trace over top of and create a sketch, which you can then extrude. So the cross-section tool is very useful and vital for reverse engineering applications. So you just need to give it plenty of time to transfer the auto surface. If you didn't want to use an auto surface, let's say you're just 3D modeling or creating a part to mate to the part that you've scanned, you can just extract the planes and the circles, for example, in peel.cad, then send only the mesh over to SolidWorks to just visualize the object there. So it doesn't have to be an auto surface. Okay, so the auto surface has been imported into SolidWorks. So we're just going to have a file and save. And we're going to put that into the folder that I've been working from. Cool, and we just jump back into peel.cad and just save that drawing or that 3D model as well. And we're going to finish off in part 3, how to then use the entities inside of SolidWorks.